Hello, this is Group 31 in Chemical Engineering 342 during the fall 2014 semester at the University of Michigan. The purpose of this project is to design an experiment that is suitable for high school students, which effectively demonstrates a mass and heat transfer concept that will expose students to chemical engineering. The experiment we have decided to perform is to show how temperature affects the diffusivity of liquids through various solids. Using the Einstein-Stokes equation, we predicted that as temperature increases, liquid diffusivity also increases, and to demonstrate this, we designed an experiment that would vary temperature and measure diffusivity, keeping other variables constant. To do so, we will take a liquid, either water or vegetable oil, and let it diffuse into a sponge, paper towel, or a cloth over a set period of time. We recorded the distance each liquid traveled up each solid to determine the diffusivity of that liquid. To perform the experiment, we took water that was heated to 95 degrees Celsius, added a few drops of food coloring to ensure that we could track its progress up the sponge, and we let the sponge sit in the water for roughly 30 seconds before removing it and marking how far the water had diffused up the sponge. We repeated the same procedure using water at room temperature and also at near freezing temperature, but also using different solid mediums such as paper towels and heavier cloths. We also repeated the same procedure, substituting vegetable oil for water at each of the same temperatures as before to verify that liquid diffusion was indeed temperature dependent. This process is an example of pseudo-steady-state unimolecular diffusion. Steady state means that a process is continuous and does not fluctuate over time. Our process would have been steady state if the water and oil levels were replenished or had remained constant as diffusion occurred, but we say that our process is pseudo-steady state or almost steady state because there is a slight decrease in the water and oil reservoir levels as the liquids diffuse upwards. This difference is close enough that we assume that it does not significantly affect our diffusion rates. Unimolecular diffusion is where one species, species A, diffuses into another species, species B. In our experiment, species A, the water and oil, diffuse into species B, the sponge, the cloth, or the paper towel. The solid sponge does not diffuse into the liquid water or the oil. As chemical engineering students, we study various diffusive processes, which helps us analyze what drives many chemical systems. Doing so, we can understand these chemical processes better, which helps us become more effective as engineers.